To Halton are debunking redshift. Redshift is just the light is moving towards the red end of the spectrum as opposed to the other end of the spectrum, which is the blue end, right? Ultraviolet blue. It's very simple. The idea is that the further away something is moving away from you, the more redshifted it will be because it's going away from you, kind of like an ambulance passing you, and then the sound changes as it gets further away. That's the idea. So they see redshift and they're like, okay, we have to interpret that as accelerating and expanding away from us so that it makes it look like we're in the center, even though we're not. Now, no matter what any heliocentric apologist tells you, that is objectively what happened, okay? They had to change the model because of what they saw. Edwin Hubble himself said that if we're wrong about our interpretation of redshift and it's not recessional velocity or like effectively a Doppler effect, right? If that's not what it is, then the universe is actually closed and finite, much more dense, everything is much more local, and might I add, suspiciously young. That's what Edwin Hubble himself said. Of course, he's the one that came up with it, which is why the supposed rate at which the universe expands and accelerates is called the Hubble constant. Just look.
What Witsit doesn't seem to understand or wants to present is there are things called Cepheid variable stars. These stars change from a minimum brightness to a peak brightness over a certain period of time. And if you know the relationship between the brightness and the period of time, you can figure out how far away they are because they appear to be dimmer. So to calibrate the redshifts, they used the Cepheid variables. Also, they used supernova type 1 stars. These are stars that are white dwarfs that are orbiting larger stars, and the outer layers of the outer stars are collapsing onto the surface of the smaller star, and eventually this ignites for a small period. If you look at Corona Borealis sometime this fall, one of these will go off because it has a period of about 8 years. But the thing is these things usually come within a certain range of brightness, so they can be, you can determine how far away they are because how much dimmer they appear in a receding galaxy. Also, their modern techniques include using binary stars, because when a binary star passes, a smaller star passes in front of the larger star, you can figure out how bright the larger star is and figure out the overall brightness in the system and figure out the distance. And that's good for local galaxies such as the Large Magellanic Cloud, Small Magellanic Cloud, Andromeda, and a few others. But this helps calibrate the Cepheid variable calibrations. There's also what they call the tip of the red giant branch. These stars are about less than 2 solar masses, and when they accumulate amount of helium in the center of the star, and a ash or unused hydrogen falls onto the core, and when there's enough of this hydrogen, it ignites, and then it also ignites the helium, and this what's what they call a helium flash. And these stars usually tend to be within a certain brightness and a certain mass, so they are used as ways of calibrating the redshift. Halton Arp was an astronomer who did a lot of observations of galaxies and found these peculiar galaxies, and he also didn't like the Big Bang Theory. So what he what he thought was that what we call quasars, which are these bright in the radio region galaxies, weren't actually as far away as people thought. They were actually ejected from nearby galaxies, and there appeared to be dust between the two galaxies, and he thought this was a connecting bridge, but this is mostly an optical illusion. But a lot of alternate space theorists, like the electric universe or whoever or whatever, seem to gravitate to Halton Arp because they think it proves that the universe is not as big, or the Big Bang didn't happen, or whatever. But no, Alston doesn't get what was going on with the redshift. Okay. Okay, I think I'll leave that at that for tonight. But yeah, it's just a short little debunk, but it was a short little video. I hope everybody has a good day or a good night, and hopefully you'll watch this video. Bye.